In a similar argument for what we used for the ratio test, we can now introduce the root test. The root test is based on the same principles relating to geometric series. So when we consider a geometric series, one way that we could determine the value of r was by taking the ratio of consecutive terms. Another way to get the value of r would be to take a root of one of these terms. For example, when we have r to the first power, we could take a first root. R to the second power, we could take a square root. R to the third power, we could take a third root. Or more generally, if we have an nth power, we could take an nth root. So with that in mind, as long as something is acting like a geometric series eventually, we'll be okay. So with that in mind, we're going to consider the limit as n goes to infinity of the nth root of the absolute value of the nth term. Let's assume for a moment that this limit exists, and we'll refer to it as L. We are allowed to draw the exact same conclusions about this as we are regarding the ratio test. So if L is less than 1, the series converges absolutely. Similarly, if L is greater than 1, the series diverges. There's no need to do any additional tests after that. And finally, if L is equal to 1, the test, like the ratio test, is inconclusive, and you'll need to try something else. Now, times when the root test is actually useful. This is going to be the tough stuff. The root test is incredibly useful almost never. There are very specific situations where the root test is very useful. One point where it's very useful is when you have a variable raised to a variable power. Anytime you have a variable raised to a variable power, it is incredibly useful. Also, if you have a number raised to a variable power, it is quite useful. Unfortunately, those are basically the only times that this thing is actually useful. If it's something that's similar to one of these and you can't use the ratio test, or can't use the root test for it, I would recommend going with the ratio test because it should work out pretty well.